Hello, everyone. Good evening. I will introduce our project. Today, I'd like to talk about a project involving nested petrolets, which has three main goals. Next page, thank you. Firstly, what's a nested petrolet? A petrolet is a graphical tool used for modeling and analyzing systems. It consists of places, transitions, and arcs, and can represent communicate behavior such as concurrent process and resource sharing. Uh, a listed petronet is an extension of natural petronet, where a petronet can be embedded within a place of other petronets. This allows for modeling of systems with hierarchical structures and multiple levels of abstraction. Now, on to the project goals. Next page, thank you. The first goal is initialization of listed petrolet. This involves creating a user-friendly interface that can display a petrolet and is hierarchical in a clear way. The interface should allow users to easily navigate through the different levels of abstraction and view the underlying structure of the model. The second goal is import, export, or nested petrolet. This means developing or matching them for importing nested petrolets from other tools or formats. Finally, the third goal is simulation or nested petrolets with probabilities and times. This involves creating a simulation agent that can handle the probabilistic nature of listed petronets, as well as incorporating timing constraints to represent real-world system. Yeah, I finished my part. This part belongs to Zhonghui. Thank you.
We have 2 points about existing modeling problems, such as these photos. Complex systems always make people confused. So the first problem is modeling and analyzing complex systems. For example, climate change systems. There are numerous unrelated factors that affecting system analysis. The second aspect is that of multi-level structure systems, involving interactions and influences between levels. For example, the study of organizational management system. There are interactions and dependencies between these levels. Without NP-NATRI models, the modeling and analysis may require another cumbersome methods, especially in multi-agent distributed system. It could use to solve difficult problems. NP-NAT is a special type of PetriNet because NP-NAT are an extension of PetriNet. They contain other PetriNet at their places and transitions. It is modeled for hierarchical multi-agent systems. And there are 3 parts about importance about NP-NAT models. First is less coupling between models. For either a reflecting and extension, NP-NAT also supports the concurrent exclusion of multi-models. It has autonomous behavior, which can improve the efficiency and performance of the system. It also supports the modeling of multi-levels and the establishment of connections. This model can either to modify. In addition, it is used to describe the interactions and dependencies between multi-subsystems. For example, when PatriNet A have to triggered by PatriNet B, NPNet can describe this relationship very well. Last but not least, NPNet can copies on as their elements have their own structure and behavior, and their number is unified. Let's turn to Xiaoyi.
Well, Zhonghui just talked about the importance of the project, and I would like to talk about the timing of the project. We plan to have 4 steps for the project. The first one is the visualization of a nested petronet, and we would like to use some libraries like Graphics or Matplotlib, and this will take about 2 weeks, and we plan to finish this part during week 5 to week 6. And the second part is the import or export of a nested paranite, and this will take another 2 weeks. We plan to complete this part from week 7 to week 8. And the next part is a simulation or a nested Petri net with probabilities and times. We would like to use some libraries like PetriNet Simulator or PyPetriNet Simulator, and we plan to finish this part in another 2 weeks, from week 8 to week 9. Next page, please. Well, the last part is the testing and modification part, and we would like to test the model and see if there are any errors. And this part will be completed within 2 weeks, and we plan to finish this during week 11 to week 12. In conclusion, we can finish the project within 12 weeks and hand in the project within this semester. I have finished my part, and the next part belongs to Chu.
Yeah, thank you. Let me show you about exciting development in the field of computer science known as nested nets, which is what we are going to be building about. The extension builds upon the traditional nets model and adds new layers of complexity, making it more suitable for very sophisticated real-world applications. Nested nets extension involves using multiple nets that can be used within one another. They can be nested also within one another. This allows for the modeling of complexity systems and multiple levels of abstraction. The nets can be communicating with one another, allowing for the transfer of information and action between all of them within different levels. One of the key advantages of nested nets towards the traditional one is that it can do model in a large scale. For example, it can be used to model complex manufacturing process. It can be delivering your knowledge spectrum, and also by breaking down these systems into smaller, more manageable units, it becomes much easier for the manager to analyze and do optimization based on their performance. With all the applications, we are really looking forward to a platform, a really cool tool, a really one shoe for all editor. This this extension is so powerful that everybody is looking forward to, and it allows us to better understand how these systems in the real world operates, and once we have achieved the knowledge, we can do it easily. Thank you.